Since Pluto's discovery in 1930, researchers have made great efforts to learn as much as they can about the tiny astronomical planet 4.6 billion miles away. Because of advances in technology, we have been able to continuously improve our understanding of Pluto, learning new things about its size and distance from the Sun, and even track changes in brightness. Scientists were particularly interested in clarifying and improving Pluto's peculiar orbit. But an unexpected new find on Pluto raises the potential of life. Why does Pluto seem off? What form of life, if any, exists on Pluto? Join us as we explore how NASA just detected that Pluto is acting strange. The 9th largest and 10th massive object known to orbit the Sun directly is Pluto. The diameter of Pluto is roughly 1,400 miles, that's 2,380 kilometers. It's roughly equivalent to the width of the Moon, or half the width of the United States. Although it is marginally less massive than Eris, it is by far the largest trans-Neptunian object by volume that is currently known. Unlike inner planets, Pluto is much smaller and largely composed of ice and rock, like other Kuiper Belt objects. Pluto is 1/3 the volume and 1/6 the mass of Earth's moon. The majority of the atmosphere on Pluto is reportedly nitrogen gas. Pluto's orbit is slow because it is 40 times further from the Sun than Earth. One orbit takes an hour, which is equal to 6.4 Earth days or 153.3 hours. It was discovered by American astronomer Clyde Tombaugh, and until 2006 was believed to be one of the solar system's 9 planets, along with Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The planet is notable for its distinctive icy mountains and small size. About 84 years after Neptune was discovered, Clyde found Pluto at the Lowell Observatory in Flagstaff, Arizona. The International Astronomical Union demoted its status and designated it a dwarf planet because it didn't match the requirements for being classified as a full-size planet and was just 2/3 the size of the Earth. 5 moons are thought to be orbiting the dwarf planet, according to astronomers. Charon, Styx, Nix, Kerberos, and Hydra are the names, with Charon being the closest to Pluto and Hydra being the farthest away. Scientists weren't even looking for Charon when it was found. When researching Pluto's orbit in 1978, James Christie became aware of a strange glob protruding from the planet's side. Christie and his crew could see that this blob would return to the same location every 6.39 days, proving that there wasn't a malfunction with the equipment. Christie and his colleagues kept checking to see if their interpretations of the observations were accurate, using old pictures of Pluto. It was revealed that they have verified the discovery of Charon on July 7, 1978. Our solar system's planets and moons have mythical figures as their names. In the instance of Charon, the term is derived from a ferryman who crossed the river Acheron with souls. Acheron is one of 5 mythical rivers that surrounded Pluto's underworld, which is named after a Roman underworld deity that is also known as Hades in Greek mythology. But why is this particular ferryman on this particular imaginary river? Charlene, the name of James Christie's spouse, isn't all that dissimilar from Charon. Pluto and its moons have been studied by astronomers for the 45 years since Charon was found. The New Horizons spacecraft's approach to the Pluto system in July 2015 showed us that Charon is its own magnificent world, not just a blob hanging off the side of Pluto, as scientists had previously thought. Following its 2015 flyby of Pluto, the New Horizon is still rewriting almost all of what is known about this minor planet. Mountains, valleys, glaciers, plains, and craters can be found on the cold globe, which has an average temperature of minus 232 degrees Celsius, that's minus 387 degrees Fahrenheit. You would see blue skies and red snow if you were to stand on the surface. Pluto has a rough patch that stands out from the rest of the small world and the rest of our cosmic neighborhood, according to a new photo study. Researchers discovered a field of enormous frozen volcanoes that are unlike anything else in the solar system. The Picard Mons and Wright Mons are 2 of the biggest. Wright Mons stands between 4 and 5 kilometers tall and is 150 kilometers wide, while Picard Mons is 7 kilometers high and 225 kilometers wide. One of the largest volcanoes on Earth, Mauna Loa in Hawaii, and Wright Mons are thought to be comparable in size. The domes, visible in the photographs, occasionally combine to form even larger mountains. What then might have produced them? Ice volcanoes. Ice volcanoes have been observed elsewhere in our solar system. They alter the topography by bringing subterranean material to the surface. In this instance, water swiftly turned into ice when it came into contact with Pluto's sub-freezing surface temperatures. These landforms have a highly distinctive appearance from any volcanoes in the solar system, even icy and rocky ones. They are shaped like mountains but lack a crater at the top and are covered in sizable bumps. Although Pluto has a rocky core, researchers have thought that the planet lacks the necessary inner heating to promote volcanism. There would have been a number of eruption sites to form the region. The lack of impact craters in the area, which are visible across Pluto's surface, was also noted by the research team. This indicates that the ice volcanoes were active recently and that Pluto's interior has more residual heat than was anticipated. This indicates that Pluto contains more interior heat than anticipated, proving that our understanding of how planetary bodies function is incomplete. In terms of geological age, the ice volcanoes were likely generated in several episodes and were possibly active as recently as 100 million to 200 million years ago. Cryovolcanoes resemble volcanoes on Earth in certain aspects because Pluto has a large portion of its surface covered in ice and because its temperatures are much below the freezing point of water. This implies that liquid water, or something similar that is at least somewhat fluid or mobile, would behave similarly to magma on Earth, rising to the surface following an eruption and solidifying or freezing. It might appear a little different than you imagine if you saw an ice volcano erupt on Pluto. When it poured out of a volcanic vent onto Pluto's surface, the frozen substance was probably more like toothpaste or a slushy mixture of ice and water. Pluto's surface is so chilly that liquid water cannot last there for an extended period of time. The enormous domes that we can sometimes see, as well as the uneven topography that permeates this region, were created by the flow of material in some situations. Cryovolcanoes on Pluto resemble shield volcanoes on Earth in certain ways. Instead of thinking of an eruption like Mount St. Helens or Vesuvius, picture the volcanoes on the Hawaiian Islands. Yet unlike what scientists believe occurred on Pluto, shield volcanoes often emerge from incredibly liquid lava. A caldera, which is the depression in the center of some volcanoes on Earth and other planets, is created when a newly erupted volcano collapses into the space left by all the debris it spewed forth. Even though Mauna Loa, a shield volcano in Hawaii, is one of the greatest volcanoes on Earth and has a relatively modest caldera, the two structures are similar in volume. The depression on Right Mons is so deep that the volcano would have had to lose almost half its volume to be a similar shape. The team aboard New Horizons was only able to see this region for about a day. However, they were unable to observe any active ice volcanoes at the time of the flyby. The ice volcanoes could well still be erupting. These might resemble Earth's volcanoes, which go dormant for a while before becoming active once more. So, is there life out there? Finding these ice volcanoes may indicate that Pluto once had a subsurface ocean. If so, liquid water may be present near the surface of the planet. The results also suggest that Pluto's interior is warmer than previously thought, which raises intriguing issues regarding Pluto's possible habitability. Although every organism trying to thrive there still faces several difficulties. They would still require a consistent source of nutrients, which can be difficult for species if the volcanism is episodic and the heat and water availability fluctuates. Pluto's interesting subsurface would entail the launch of an orbiter to the faraway planet. We could also use ice-penetrating radar to peek directly into Pluto if we sent a future trip, and we could even be able to see what the volcanic plumbing looks like. Thanks for watching another episode of Voyager. While you're still here, make sure to click